Solve x cubed plus 8x squared equals 4x minus 32. This one's a bit more complicated because there are more terms, and we have an x cubed term here that we didn't have before, but we can still use the same methods that we've been using to solve this. The first step is going to be getting all the terms on the same side. So we need to get rid of this 4x and the 32 on the right, so we can subtract them from both sides. We're going to leave the x cubed and the 8x squared alone. But if we subtract 4x on both sides, that's going to get rid of the 4x on the right. And if we subtract 4x on the left, that's going to give us a negative 4x on the left. And similarly, we can subtract 32 on both sides. That gives us a negative 32 on the left. And on the right, everything's canceled, so we're left with 0. So this gives us x cubed plus 8x squared minus 4x minus 32 equals 0. And now that we've got all of the terms on the left-hand side and the right-hand side is just 0, we can factor the polynomial on the left. And this one's going to be factored by grouping. So I'm going to group the first two terms and then the last two terms. In the first group, both of those are divisible by x squared. So I'm going to pull out an x squared, and that leaves me with x plus 8 as leftovers. In the second group, the GCF is going to be negative 4. So we're going to pull out a negative 4, and that also leaves us with x plus 8. So both of those groups had an x plus 8 as a factor, so that's going to be the GCF of the whole problem. And then when we pull that out, we're left with x squared minus 4. But many of you are noticing right now that that x squared minus 4 is a difference of two squares, and it can be factored even further. We're going to keep that x plus 8 out front, but then x squared minus 4 is going to factor into x plus 2 times x minus 2. And now we have three factors on the left-hand side, and their product is 0. And the zero factor property still holds. Even if we have three things that are getting multiplied by, if that product is equal to 0, that means one of those three things had to be 0, and so we can still set each factor equal to 0. X plus 8 equals 0, x plus 2 equals 0, or x minus 2 equals 0. And now we have three equations to solve, and that's going to give us three solutions. In the first one, we can subtract 8 from both sides to get x equals negative 8. In the second one, we can subtract 2 from both sides to get x equals negative 2. And then in the third one, we can add 2 to both sides to get x equals positive 2. And now we have three solutions: x equals negative 8, x equals negative 2, or x equals 2. In this problem, we had three solutions because it was a third-degree polynomial. The degree of the polynomial gives you the maximum number of solutions that you can possibly have. So all of those second-degree polynomials that we had, those quadratic equations, it was a second degree, so each one had two solutions at most. And here we have a third-degree polynomial equation, and that allows us to have up to 3 solutions in total. It's always possible that there will be fewer solutions than the degree of the polynomial, but never possible that there will be more solutions.